Okay, so you should have out a clean piece of notebook paper. Go ahead and get it titled so I can describe the difference between a rational and irrational number. And then go ahead and get it dated with today's date. All right, so we've already discussed rational and irrational numbers a little bit. We're going to dive into the actual definition of those words a little bit more today. Okay, so we're going to start with rational numbers. Rational numbers, we already said, could be decimals. They could be fractions if we can simplify them and they turn out to be decimals. But let's talk about the decimal piece a little bit more. Okay, rational numbers are going to be decimals. And of course, this could be fractions that turn into decimals. Decimals that decimals that do terminate. Okay. The word terminate means end. Okay. They're decimals that terminate. So, for example, a decimal that terminates is 0.5. 0.5 is a decimal and it stops. We can see the end of it in our calculator window. So the number 0.5 or the number 1/2, because they mean the same thing, those are going to be rational numbers because those are decimals that terminate. They end. Okay, or decimals that have a repeating pattern. Okay, so what I mean by that is if you type into your calculator 1 divided by 3, you're going to get 0.33333, and that goes on and on and on and on, okay? We can write that as 0.3 with the bar over top of it to show that it's a repeating number, okay? So if we can write a number with that block over a digit or a block of digits, then it's going to be rational, okay? Even though that 3 goes on forever and ever and ever and ever and ever, as long as we can write it as a shortened number, so 0.3 repeating, it's still going to fall into the rational numbers. Let me give you another number. So let's say I have 1.12121212, and that keeps on going. Okay. The repeating block of digits is the 1, 2. So I could write this number as 1.12 with the bar over top of it. So I can shorten that number that goes on forever and ever. I can shorten it by using this bar and writing that bar over top of it. If I can use that to shorten the number, then it's going to be considered rational instead of irrational. But if it is a number like 4.6281976638, and that keeps going, this is not a rational number, okay? Because there is no number that is repeating. There is not a block of numbers that I could say, oh yeah, that number keeps going over and over, okay? So this is not rational because there's no repeating block of digits. There's no repeating pattern that we could use to shorten and write that number smaller. Now, I've used this a couple times, so this is important that you know that that ... means that that number or that pattern continues forever, okay? So I'm going to just squeeze this on here. If you see the ... after a number, that means it continues, okay? There's more to come. So that pattern continues forever, that number doesn't stop, okay? Something along those lines. All right, let's look at irrational numbers a little bit closer. So irrational numbers are decimals, okay, or any numbers that can simplify to a decimal that goes on forever. So in other words, it does not terminate, so it doesn't stop. We don't see the end of it. And does not have a repeating block of digits. Okay, so if I can't write it with that bar over top saying, hey, this repeats, then it's going to be irrational. All right, so we're going to look at a couple of numbers and a couple examples, and we have to determine whether it's going to be rational and irrational. And taking it a step further, we're going to be asked to explain why we think that it's this or that, okay? Explain and justify our answers. So we're going to determine whether the following numbers are classified as rational or irrational, and we have to explain, okay? So this first one, we have the square root of 529. Well, we know that the first thing you're going to do is you are going to evaluate it. So you're going to take and hit that second button, hit that x squared button, and then type it in. When you type it in, the square root of 529 is actually 23. Okay, 23 is going to be a rational number. And it's going to be a rational number, we have to explain. It's a rational number and it's rational because it terminates. Notice it doesn't fill up our entire calculator, okay? It terminates. Okay, so we're using that vocabulary that we got from that definition. It terminates. It's a whole number, okay? So it terminates. It ends, all right? Let's look at another one. All right. 1/4. So we have to divide. So 1 divided by 4. We get 0.25. Okay? So 0.25 is going to be classified as a rational number because it terminates or ends. All right, now remember, try that strategy. Go ahead and pause the video. See if you can figure out the square root of 63. And what do you think that that is? Is it rational or is it irrational? Okay, so all right, so when I type that in, I got 7.93725, and then that keeps on going, okay? Keeps on going. It doesn't stop in my calculator window. Okay, so this is going to be classified as an irrational number. Okay, because it does not terminate or repeat. You can even go on to say it goes on forever. Okay, all of that would be considered a good explanation. Include as much of the definition that you possibly can. As always, you can pause at any point, okay? But I got to keep going so that we can get this video over with. Is 7/8 rational or irrational? Explain your answer using the definitions. Okay, so 7/8, we first have to evaluate that. So 7 divided by 8. I get 0.875. Is that rational or is it irrational? Pause the video, think about it, and then write your response. You should say that that is a rational number. And the reason why that is a rational number is because it is a terminating decimal. It ends. All right, Jonah and Frank were having a discussion about the number 4.5238. Jonah says that it is a rational number, and Frank thinks it's an irrational number. Who is correct? And explain, okay? So Jonah thinks it's rational. Frank thinks it's irrational. So our first question says, who is correct? So I have to state either Jonah is correct or Frank is correct, okay? Well, I first have to look at that number myself. So 4.5238. Well, I know that that number is going to be rational. Okay. But that's not what the question asks. The question asks who is correct. Okay? Well, here is who said that it is rational. So I'm going to answer the question and say Jonah is correct because 4.5238 is a terminating decimal. It ends. It ends. All right, as always, if I'm going too fast, just make sure you pause it. You have the ability to pause at any point in time. All right, last one. Is the number 10.5252225222 and so on and so forth a rational or irrational number? And explain. Okay? Now remember, rational numbers either terminate. This one doesn't terminate because it says it goes on forever. But we need to look at, is there a pattern? Is there a set of numbers that I could write with a bar over top of it? Now this one's tricky because it repeats the same numbers, but each time it's adding another 2. So it's not technically repeating the exact same block over and over and over and over again. It's adding a 2 every single time. So this number is an irrational number because there is not a repeating block of digits, and it does not terminate. Okay. Guys, make sure that you have taken complete notes today. It is very, very important that you are very thorough in answering these questions and using those key words and definitions in your explanations. If you don't do that on your quizzes or on your DCA or on your homework, I'm not going to count it as correct. So you need to make sure that you're using those key words when it comes to your explanations and your definitions, okay? As always, if you have a question, please ask.